Hello everyone, welcome to Computer Science E76. This is lecture 5, Intents in Storage. So you might recall from last week that we talked a bit about using some resources that are available to us. So just as sort of a quick refresher, remember that we have a resource folder, or an RES folder that's available to us in the hierarchy of our Android APK file that's provided, especially when we're using Eclipse. There's that hierarchy of folders that you are now hopefully quite a bit familiar with. And so there's a whole bunch of folders. Some of these are included by default in a typical Eclipse project or Android project when you open it, when you create one in Eclipse. But some of these you also have to create yourself. And so you can input a variety of different types that's appropriate for each of these folders. And we mentioned how there's actually this sort of silly and sort of strange, in a way, requirement that all of the file names must be named in a very specific way. In particular, they can have numbers and letters and underscores, but they cannot have, and a period also for the file type itself, but they cannot actually have capital letters within them, and nor can they have dashes and pretty much any other character that you can think of. And so if you think that you have a file that doesn't necessarily fit into any one of these particular resource directories, I don't recommend putting it directly into the resource folder without any subdirectories. All of those resources will actually be ignored. So they do actually have to be in a resource folder that Android will recognize. And so in lecture, we've talked about a couple of these, and values, for example, XML maybe a little bit, and we've seen, of course, the layout ones, and in the project you will be dealing quite a bit with the drawable directory as well. And generally, if you have files that are going to remain static in your application, they're not actually going to be modified by your application in some way. And what I mean by that is that you can modify them at runtime, but if you're not going to save the modifications at runtime, then the resource folder is sort of the ideal folder for those. And so a lot of these then fall under that sort of purview. And so we talked also at the very end of lecture last week, we were talking about using this raw folder to place some raw files within the Android APK file, and to include things like sounds and videos and that sort of thing. And so even though you have some other folders that are available to you, in particular the asset folder where you can include some raw assets, still, if you are not actually modifying any of these files or modifying them and then not saving them at runtime, then the resource folder is the appropriate choice in that particular case. And so when we started looking at the code from last week, and by the way, with a couple of requests last week, I've decided to just post all the source code that's available ahead of time. So if you are following along with a laptop, you can actually go to the website and download not only the source code zip at the very bottom, but also we've started including text notes, which describes what each of the projects, basically just a simple mapping of what each project does to its corresponding sort of demonstration. Even though there might be some other small things that we talk about in each project, it's just meant to be sort of the basic overview of what each one actually does. So feel free to download and import into Eclipse and follow along. But the first one that we're actually going to talk about is Intents 04, and this one is actually included with the source the source code from last week, just because I didn't want to include any conflicting projects. It's exactly the same code as last week, so download that one as well if you need to follow along. And so basically what this project allows us to do is just use some more resources to allow us to play a sound file as well. And so at the very end of the last lecture, we gave a demo where we start the application. We can see there is an image and there's a button, and when we hit the button, we can actually hear a bit of a sound. And I know it's a little quiet, but that's because there's no microphone right here. And so you'll notice that when this sound is actually playing, it actually changes the text within the button as well. And so the sound is still playing, sound is still playing, sound is still playing, but now it's finally over and the text actually changes back. So you can sense that there is some sort of callback that occurs when this media player has finished playing this media that allows us to run some other code that allows us to say, okay, we can reset the button or the image or what have you that you actually use to initiate this particular instance in the media. So how do we create create this. So I glossed over this very quickly last week, so I just want to be sure that we talk about it in just a little bit more detail, especially since this code, we build upon this particular application. One of the things you'll start noticing is that we're starting to build more robust applications, even though they're still a bit simple. They don't actually do very much, but we start building upon each of this code to sort of build more and more robust applications built upon the previous one. So in this case, we have an onCreate function, of course, that's meant to instantiate everything that we need to instantiate at the onset of our activity. And so the very first two lines look very familiar, hopefully. The very first thing we do is call our onCreate method from the superclass. Then we set the view for this particular activity. Then we start doing some of the interesting things. Like the next part, we actually connect that button that we saw, that button that said vroom vroom, and also when the sound was playing, it changed its text to emergency brake. We want to connect that to our code programmatically so that we can actually do something with that button. And then now this final portion of onCreate is actually the most interesting part related to what we're talking about here. For you to play some media, you'll most likely want to use this media player object. And it's not actually sufficient to just create a new instantiation of this media player. What you could do, of course, is something that looks like this, which may look much more familiar to those of you familiar with Java. You might actually be tempted to do something like this, where you actually instantiate a new media player. However, very much like the activity that we are running this in, the media player itself has a life cycle. And so just instantiating this media player does not mean that it is ready to actually play any resources quite yet. So you can use one of these other methods, like this create method, that actually does a variety of things. The first thing it does is it will actually instantiate the media player for us, and it will get it ready. It will get it to the point in its activity, or rather in its life cycle, that will get it ready to play whatever resource we have selected. So we can see that what we are doing here is we are creating a new media player instance. We're providing it the context of the application, and we are also providing to it the resource. And so you'll see that one of the resources is here, r.raw.ferrari250. And so if we were to actually look at the raw folder in our resource folder, we can see that we have here a WAV file. So, well, even though this program itself, even though the code that we have written here is not actually interpreting this WAV file, we're allowing the media player to load the file and play it back to us. Now notice that here another thing that we do is we also just set some properties for this media player. We don't want the sound to loop. You might want to, depending on the sound and the context of the media that you're trying to play. And we also need to set a completion listener. So you had seen before that when we actually started the sound, once the sound had finished playing, the button reset back to say vroom vroom, which indicates to the user that they can actually play that sound once again. This is a very useful thing. It's very much like if we were to actually use an analogy to an actual media player like iTunes or what have you. When you push play, that icon changes from the little triangle that points right to the pause symbol, that pause icon that indicates to the user that there's something going on. Then when that is completed playing, then that same icon changes back to that play icon. And so this is very important. Now you can notice that we are passing in our own class to be the onCompletion listener. So that means that at the very top of our activity, we are probably doing something to listen for this particular event. And in fact, not only are we setting an on-click listener at the very top there for our button in the case that when someone actually pushes the button, but also now are we going to implement the on-completion listener. So now we also need some additional methods that are going to implement each of these things. One is going to implement the on-click event, or the on-click method that happens when a user clicks on the button, and the other one will be a method that is called when this media player has finished playing. And so just scrolling down a bit, we can see that. We can notice that on click, we have a couple of different states. Now, if the button actually says one of two things, then we actually have to switch it to the other. So one of the things that I didn't demo before is that this same button, when it's playing the sound, you can actually hit that emergency brake and pause the sound, and it will still reset. So it's very much like a play-pause button that exists in a normal media player, just using some text instead. So now we can just use the very convenient method from the media player called isPlaying to determine whether or not it is actually playing some media. If it is, then we can tell it to stop playing, and we can reset the text to that text that we had specified before that actually indicates to the user that they can play a sound. Conversely, if it's not playing, then we want to start the media player and put that text that says that emergency break text that notifies the user that they can also pause that media player as well. So you'll notice that here, because we have actually created our media player and provided it a number of things to get it ready for it to play, this player.start method is actually available to us. If you just instantiate the media player using typical Java instantiation, you will get an error of some kind just because it's not quite ready in its life cycle, in the media player life cycle, for that to happen. Now we can, after this is done, we want to, once the sound is completed playing, we wanted to complete that this implementation by resetting the text once it's been finished. So this is very easy. We can just implement the onCompletion method here and reset the text of our button to represent to the user that we are now, that they can play the sound once again. So really it doesn't take all that much code to implement a sound player within your application. And so this is something that can be very useful for you, even though it's not required by the project. You might actually find it useful for your own project when you work on the Student's Choice project in just a couple of weeks, or actually starting with next week. Now, of course, the media player itself does support a variety of formats, and you can find those supported media types in the documentation as well. And there's a whole bunch of audio types and video types as well that it supports. Generally, there are some additional codecs that specific phones will have installed in them, but generally it's best, of course, to implement a media player that uses one of the more common codecs, just so that more people can enjoy whatever media you have for them to look at. And so there's not only audio, but image and video as well. And Google's most recent codec, the VP8 codec that they've made open source and they're using as a direct competitor to H.264, is supported by Android, but only in sort of the most recent versions of Android. You'll notice that there's a decoder available in Android 2.3.3 and up. So you notice there's actually two columns right here. The one on the right is the decoder, and the one on the left is the encoder, implying that you can actually encode some source, some video or some audio, into one of these available codecs as well. So you could actually encode H.264, but only in Android version 3.0 and up. Now this is pretty neat and useful, I think, but what if we want to take it to the next step? Then what do we have to do? Well, that is precisely the point of Intense05, where now what we want to do is not just have one sound playing, but perhaps what we want to do is be able to switch the sound as well. And so we can do this by way of using a menu. So what exactly does code 5 look like? We will run it on the phone over here. Notice that now it's actually now running, even though it looks almost exactly the same, and the button looks the same, and it actually does the same thing where we can hit the vroom vroom button and it's playing a sound right now, and we can pause the sound if we want to, but we can also now bring up a menu. So notice that there are, of course, on an Android device, 4 buttons at the bottom of the device. And it depends on the device itself how these are implemented, whether they're soft buttons like they are here, or they're actual physical buttons that you get the satisfaction of physically clicking. In this case, there's soft buttons here, but hitting the menu button, this one second from the left right here, actually brings up a menu. This menu did not exist in the previous one, but you can see that there's now 2 menu options available to us, the tortoise and the hare, where right now we have hare selected. We can select tortoise, and you'll notice that a couple of things change. Well, right now the image changes, but now we can also hit vroom vroom, and the sound has changed as well. So it sounds like a really old, pokey car, if you can't hear it very well. Okay, I'm going to make this possible for you to hear. Oops, I changed it back. That's my bad. Okay, so that's the hare, obviously, and then the tortoise sounds like this. All right, so that's the tortoise that's playing. So how do we then implement a menu? Well, realize that in order for us to implement a menu, we have to do a couple of things. First, we have to create the menu layout. And we can do this very simply, just like with many other things, using XML. And so one of the resource folders that is provided to us within Eclipse, or not necessarily provided to us, but one of the ones that we can create, is in fact a menu folder. So notice that right here in our resource directory, can we also include now a menu directory as well, a subdirectory to the resource menu. So this XML file looks a little something like this, where all we do is we just have a menu root element and a couple of item sub-elements that are meant to be each of the items that are displayed in this menu. So in this case, we had 2 items in the menu, and you can see that we have 2 here. We give each an ID, which is very useful to us, as you'll see in just a moment. We also give it a title. Now, of course, we could have generalized this a little bit, put the title from the string resource, and then that would allow us to more easily localize each of these to different languages as well. Now you'll notice that also there is an Android :icon attribute here as well. In fact, this is the icon that you saw above each of the menu items, like you can see right here. So you see right here, there's sort of one icon and there's another one. Now there's a lot of icons that are built into Android. And this is one of those cases where you should do as I say and not as I do, because we can actually reference each of these from the Android package itself. So at Android, rather than using one of our local package, we can reference the Android package as well. So notice that Android actually includes a set of drawables itself, and we can reference some of those icons. Now, you won't actually be able to find an official list of icons just because they don't want you doing this very often. And the reason for that, and this is actually a very good reason not to, is that these icons can actually change dependent on the version that you're using. So they're not really meant to be public. But you can reference them, and they will work in a variety of versions as well. And there's also a third-party resource, this URL right here, android-drawableexplorer.appspot.com, that allows you to see all of the icons that are available in one of the more recent Android packages. And so you'd then be able to find the appropriate name and update the icon attribute appropriately. Yes?
What does reference one of those packages mean exactly?
What do reference one of those packages?
System, or what?
Oh, you mean the @Android?
Yeah.
So by default,
No, I don't. I mean the bottom line in the XML comment.
Find a full list of Android package drawable resources. So just like our own application provides or can provide a number of drawable resources, icons and images that we might use in the application, so does Android have a set of built-in drawable images as well, which includes a lot of the icons that you would see when you are visiting, or when you look at, say, the menu at the home screen, for instance. So all of these icons are actually built in and can be accessed by referencing the drawable section of the Android package. And so what this third-party browser allows you to do is just look at very easily, and I guess there's no reason for me not to show it to you. What it allows you to do is you can actually see the list of drawables that the Android package itself actually contains. And so all of these are the drawables that are available, and you can see there's a whole bunch of icons here. If we scroll down a little bit, we'll be able to see some menu ones pretty soon. I see. So all of these are sample menu icons that you could potentially use in your own menu. The problem with using this is that, of course, like I mentioned before, these could actually change. So if you actually wanted to use one of these icons, what's better, rather than referencing them directly from the Android package, just because that means the compatibility of your app might decrease in a certain sense, what you should do is perhaps copy the drawable resource to your own drawables directory and then reference it locally instead. That's just sort of a safer way of referencing each of these menu icons. So realize that these menu icons do exist, and there is an unofficial way of looking at all of the drawable resources available in the Android package if you don't actually feel like creating one of these yourself. But you'll just have to take note of this particular problem, in that they can actually change, and some of them actually are not publicly available, in the sense that the ones that you see here, and if you create an application that's targeted for an earlier version of Android, some of these might not actually exist in an earlier version of Android. And so you might reference one of them and get some sort of weird error like permission denied or some similar thing. You'll just have to know that you won't be able to use that particular icon. However, copying it is certainly a way of getting around this particular limitation. So if you wanted to reference then one of your own drawable resources, you would of course not reference the Android package, but you would then reference your own package. Now this wouldn't work in this case because there is in fact nothing in my own local drawable folder except the icon that's used for this particular application. So in the drawable folder, okay, well, and those two images as well that are used in the image view as well. Okay, so we define then a menu using this XML file. Now, of course, just like you can define a layout programmatically, you can also define a menu programmatically as well. And we don't have an exact demo of that, but I will mention how you will be able to do that in just a moment. I think I saw a question in the back. Yep. Can the icons be sized in the XML? No, the icons are assumed in versions earlier than 2.2 or 2.3 or so. I don't remember the exact version. Icons earlier than a certain version are expected to be 48 pixels by 48 pixels. Anything other than that, it doesn't even resize it. It just tries to show it. So if you have a bigger one, it will just be absolutely massive and take up the entire, not the entire menu, but the entire button in that menu, and it will look just sort of silly. Anything smaller than that will sort of be similar. It will just be a little bit too small. There are actually design guidelines that Android provides, what you can do is then, if you were very serious about making your own application, you can actually follow these guidelines in order to create your own menu icon. So when this loads in just a moment, what you will see is that and they really go into quite a lot of detail about not only menu icons, but also launcher icons as well, so that you can design your own icons for the application itself. So we can scroll down. Oh, let's see, where's menu icons? I actually followed one of these a little bit earlier today for some menu icons that I'll show you in just a little bit. So they actually go into a lot of specifics about how you can design an Android-looking icon. So they actually give you all of the specifics that you might use in an application like Adobe Photoshop to actually create an icon that looks very much like some of the icons that you would find elsewhere. So Android 2.2, so that's the version that requires icons that are 48 pixels by 48 pixels. And it also, I mean, as you can see, there's a whole bunch of guidelines that are provided here, and also a color palette. If you're using a more recent version of Android, then you can actually include icons that are different sizes dependent on the DPI of the device as well. So all the way from 36 pixels square all the way up to 72 pixels square, with the 48 pixel sort of being the default intermediate value. Okay. So coming back to this, so now we've defined our menu in the XML file, but how do we actually load it in our application itself? And so if we take a look at code 5, there's a lot of similar stuff that we can see here. Notice that we actually have a new method called setCar, and we'll talk about that in just a moment. But one of the methods that you can implement that Android will actually call automatically is this onCreateOptions menu. So what you need to do is just override this function that exists, or this method that exists in the activity class. And by doing so, you are then able to define your own options menu dependent on, say, the XML file, or whether, or even doing it programmatically if you want. So in this case, we've defined it in XML. So all we have to do is then just retrieve that XML file and do something that's called an inflate. So we inflate this XML file into actual objects, and then we can tell the menu what it is that we want to do. So in this case, notice that we're using a menu inflator object, and we're passing into it the options menu that we have created in our resource directory, and we're also passing into it a menu object that's passed into us, the onCreateOptions menu. And what this will do is it will actually then create the options menu into that menu object. Now by default, we return true, which implies that we were successfully able to create our menu. But if we were doing this programmatically, we might want to do some tests, make sure that everything has been created properly. And if it is not, for some reason, if there's some sort of failure, we would then return false, indicating that we were not able to create our menu. I think I saw a question.
What would be the equivalent in Java, or is it sort of like Toast? It's not quite.
I'm not sure there's an equivalent in Java, but basically an inflator is something that's used in Android to take an XML file and interpret it and make basically create objects from it. So in this case, a menu inflator will read the XML file that we've just defined and create the menu and then both of those buttons that we saw that we have defined, those menu items that we had defined in the XML file. So there's also inflators that exist for layout, for example, and for a number of other XML, or maybe not a number, but those are the two major ones that you will see typically, menu inflator and layout inflator as well. So you can actually inflate a layout as well. But in this case, we just want to use it. We have a very simple menu. We don't have to define it programmatically. So we can just inflate the XML file that we have and return that back to the, or rather return true, saying that we have successfully done it and that the menu object now contains the menu that we want to display. So now, what Android will do, what the activity will do is actually show the menu to the screen. Now when a menu option is selected, then we have to implement another method as well that actually does something when an item has been selected. So in that case, we want to create an onOptionsItemSelected method. So both of these are hard-coded. They're not something that we would define elsewhere. It's just what the activity assumes that we have implemented when we want to implement one of these menus. In order for us to create the menu, we have to define onCreateOptionsMenu and accept one parameter called of type menu. And then when we want to do something with the selected item, then we have to create this method called onOptionsItemSelected and pass into it an object of type menu item. So in this case, when something has been selected, we're going to pass that ID that has been selected into this method that I referenced before called setCar. Then we'll return true, indicating that we have in fact dealt with the selected item in this case. So what does setCar actually look like? That is up here, and basically the difference is going to be what happens, what changes in the activity. So you might recall that there was an image view and then a button immediately underneath it. So there's two things that have to change. First of all, the media player has to be updated to use the new sound. And by the way, we are now including that sound in our raw directory. So we can see that we have an early car engine.wave and a Ferrari 250.wave, one for each of these two options. So when an appropriate button is selected, then we have to instantiate the media player with that new sound, and we also have to then change the image to reflect the new image that's selected by the user. So in this case, what we are going to do is have a switch dependent on the ID that was passed to us. Notice that we are passing in an ID in this particular case, and we're going to have a switch that decides what action to take dependent on the selected item. In the case of the tortoise, then we will set the player to be the one that uses the early car engine. In the case of the hare, we will use the latter, or we will use the Ferrari engine to make it sound like it's much faster, and we will actually change the drawable, or we will change the image resource to update based on the drawable that exists within our folders as well. Now notice that there's something that we do up above. If player is not equal null. What this means is that the player has already been instantiated, and so what we want to do is actually reset it, just to say that we do not, that player is free to be let go, and we can actually now recreate a new player using the media player.create option. So after you reset the player, can you no longer use the play option from it. You'll actually have to reinstantiate something. Now, of course, one of the things that some of the options that we wanted, the set looping false and using the onCompletion listener to maintain that text change on the button still exist here as well. But we just do it for both of these options just because they are the same options for both. Any questions on this stuff? Okay, so taking a bit of a change now, one of the things that we're quickly approaching the point where we can do a lot in one activity, but now one of the things that we're going to want to do is perhaps open up a second activity. So we want to create this sort of nested look within our application. And so in order for us to do that, we have to use an object called an intent, and it's going to appear in just a second. So using an intent, you can actually launch a variety of things, not just new activities, but you can also launch services and broadcasts as well. And basically, an intent is just an object that you might use to pass some data from your own activity to any subsequent activities as well. And you don't have to necessarily pass data to it, but you would still use an intent object to notify the Android OS what it is that you want to do, what it is that you want to launch. And in many cases, especially in the case of our project, the NPuzzle project, you're just going to want to launch a local additional activity, another activity that exists within your same application. But note that you don't have to launch activities only local to your application. It's actually possible to send an intent that launches some other activities as well. And so we had talked about this before, this concept of a task rather than an application. A task is just a stack of activities, and all of these activities don't necessarily have to be from the same application. So we might have, for example, this SMS app that we used as an example a couple of weeks ago, where you have a contact list that might actually appear, and this contact list might not actually be your own activity. It might actually be another activity from another application, like the address book or the contacts application that exists on the phone itself. So in this case, the Android will actually find the appropriate activity and launch it and pass to it the data that we have specified within the intent. Yes?
Can you use an intent within an activity to restart that same activity?
Can you use an intent within an activity to restart that same activity? I've never actually tried it, but I don't actually know, but I would presume that what would happen is Android might actually try to launch the same activity on top of itself. I don't actually know if it would allow that to happen. I don't think it would be reset, though. You would have to use something different in order to reset your own activity. You might actually factor out the code in your onCreate method and put that into a separate method altogether, and then and just call that method to reset anything and let go of any objects that might exist within your activity. Okay. So how then are we able to create some additional activities? And that's the point of code 6. Now notice in the source code directory here, do we now have a second Java file? And this is sort of now unique. We haven't really seen much of this before, but each of these Java files represents its own activity. And we'll talk more about how you can create one of these Java files in section. But basically in Eclipse, if you want to create a new activity, you go to File, New, and then Class. And I know that's off screen. But from here, you give your class a name, just like you gave your initial activity a name. And you'll notice that one of the options that's presented here is the superclass. And it shouldn't be a java.lang.object, but it should, in fact, be an activity as part of the Android package. So how you can find that is you click Browse, and then you just start searching for activity. Notice that activity-Android app comes up. That's the one that you want. And then you give your activity a specific name. And most of the other options, until you get more advanced, almost all of these are fine just to leave at their default. Then after you type in a name, you click Finish, and then it actually adds an activity to your source directory. And it's just going to be the most bare bones of activities. It's just going to say the public class, then the name, extends activity, and there's not going to be much else. So right now we have two activities. We have code6.java and we have thumbsup.java. So what actually happens when we run this application, just to show you what happens with this is, wait, what does this say? Select the resources to save. I don't want to save any of these. And now it will install onto the device. And hopefully, all right, so now we can see that there is, I'll zoom in a little bit. There is this text, can you start a new activity? So if I hit no, then what's going to happen is the application is going to quit. But what happens if I click yes? I have to go back to it again. It was intent 06, I believe. And you can see it says here, can you start a new activity? I hit yup. And what happens is that the screen now changes to reflect this new activity. We get a thumbs up with an entirely different layout, as you'll notice. No longer do we have two buttons, but this is an independent, unique layout only reserved for this activity in this particular case. And it says there's a button here that says thanks that I can click to return back to my original activity. Now notice what Android does when it switches from one activity to the next. It sort of does this swipe motion as well. And so that's just sort of an indication to the user that there's a new activity that has appeared in this particular case. So now that we've seen how this works, let's see what actually happens. So when we look at the code6.java file, this is the default activity that appears when we first load the application. And so recall that in our manifest file, we actually had something called an intent filter that defined what the main activity of the application was. And so this is the manifest file for that same application. Now notice that we have here the code6 activity, and one of the intent filter is this main and launcher. So recall that we're talking a bit about intents, and in fact, how Android decides what activity to load depends on this intents filter. Now notice another thing is that we've actually specified the second activity in this manifest file as well. This is something that you have to do. If you're going to have more than one activity in your application, you must update your Android manifest file to reflect this that you have a second or third or fourth and so on activity. Otherwise, Android will not find that activity within your application, even if you have the Java file in that source directory. It's not going to find it and it won't use it. You'll get an error instead. So make sure that whenever you include or whenever you create a new activity in your source directory, that one of the things that you do is create a new activity element and give it a name within your Android manifest file. Now, of course, we don't want to give it an intent filter of main and launcher just because only one activity will be the main activity that gets launched when the application is initially run. So with this, now we've notified Android that we have two activities that we actually want to do, or that we actually might use within our application. So the very first thing that we do in our main activity is just some sort of house cleaning stuff that we've seen before. We create the view, we create the layout within the activity rather. We connect via code to some of the buttons that exist within the layout. And then when one of those buttons is clicked, we want to do something. So in the case that yes was clicked, we're going to create a new intent and pass that intent. We're going to start an activity by passing the intent to this to a new method. But the very first thing that I'll show you is this: what happens when we click no. If we actually want to close an activity, we will run this finish method right here. A finish method running somewhere will close the current activity. And if this is the only activity that's open in the application, what this means is that your application will actually close. It will actually be quit. But in the case now that we hit yes, what we want to do is actually open up our new intent. So now notice this is actually pretty simple. There's not many lines of code. In fact, there's way more comments than there are code itself. There's two major things that we have to do. First, we create the intent. So we create an intent called I, and we instantiate a new intent object. We pass into it the current context and also the intent that we want to open. Now this is the case when we have a local intent that we want to actually open up within our own application. Now notice that we actually want to run thumbsup.class. We actually provide to it the class file that is generated. And notice that the other source code file that we have created here is called thumbsup.java. So basically whatever your other activity is called, you will just rename that from whatever.java to whatever.class, and you will pass that into this new intent object. Then after you've created that intent object, then you can run the start activity method, which is provided to us by the activity superclass, and you can pass into it this intent object, and Android handles the rest. It's not that difficult, really. It's actually pretty simple to start a new activity. This is really all that you have to do. Now, of course, I know many of you will forget to do this, so don't forget to put your activity in the Android manifest file. Yes, you're going to have to update that manifest file every so often, and it's important to remember to be able to do that. If you start getting some crashes or some weird behavior when you're trying to create a new intent for your own activity that you've created and included in your package, make sure that you have included it within the Android manifest.xml file. Any questions on this? Yes?
On the line where you instantiate the intent,
Uh-huh.
that I as opposed to intent, what does this, the first part which is
This.
indicate? Yeah.
This is just providing the context. And so this, we could have used something different altogether, like I believe it's using a context here, so we could have done get application context. The context really just refers to the current application itself, and it's just one of the things, a variety of classes within Android actually require context, and the intent happens to be one of them. Yes?
So when we start an activity, does our current activity go to sleep and wait until we kind of exit that other activity, or does it continue executing concurrently?
That's a very good question. So what happens when we open up a new activity? Does it actually create now or does it actually cause both activities to be run concurrently, or does it cause one of the activities to be shut down? Well, recall that we have an activity life cycle that we saw, that we first started talking about when we first started talking about Android in general. And there was this very specific set of methods that are called in an activity when something happens to it. So within this activity, so this is the same documentation for an activity, and we had this diagram here. When an activity starts, it goes through a certain sequence of methods to actually open up this activity. And this is precisely what happens to our new activity. Our new activity is an entirely new activity, so it goes through the same sequence of steps where it is created first, and then it is started, and then it is resumed, and then the activity is actually running. But before any of this happens, Android has to actually pause your current activity. There can only be one activity running at the same time. You're not going to have concurrent activities. All of them are going to be, anything that is not in the foreground is essentially going to be paused. So once the activity is running, if something else comes in front of that activity, say another activity comes in front of the current one, it is going to be paused. So our very first activity, our main activity that we saw with the two buttons, is paused first using the onPause method. It calls the onPause method if one exists, and then the other one goes through the beginning of its life cycle. It's created, is started, and then it's resumed, and then that activity is now running, and it's actually in the forefront of your task, of the application that is running. And so recall that we had kind of this complicated look at what can happen to an activity that is in the background. Once that activity has been placed into the background, once our initial activity has been paused, there is actually nothing stopping Android from killing it altogether at that point. It hasn't been killed yet, especially if it can avoid it. It's going to try to keep all of those objects in memory just so that the user experience is a little bit better. But if your new activity uses up a ton of memory and it's really causing a strain on system resources, or even if there's just a variety of other activities or services that are straining the resources of that particular device, then what can happen is that a paused activity that is in the background can actually be killed, just like through this normal life cycle that we have seen before. Mm-hmm.
So you're saying that Android will execute that onPause method.
Right.
Will that happen in the same thread of execution that involved the start activity method?
Will that happen in the same thread of execution that causes the new activity to be started? I believe each activity...
I'm asking about the onPause method in the initial
Right.
activity. Will that method be run in the same thread of execution that
Oh, yes.
start activity method? So
In activity, Android has a single-threaded model, which means that everything within your activity occurs in the same thread unless you explicitly create a background thread or a new thread, and we'll probably talk a little bit about threading next week. So onPause actually happens within the same thread that all of this other stuff has actually been run. So if you are updating a lot of UI events, for example, onPause would be a good way to pause one of those UI events from occurring and do any sort of necessary save changes. And we'll talk about storage a little bit later, where you might actually want to use onPause to save the state of your running activity, because once onPause has been run, that activity can actually be killed at some point. So if anything comes in front of your current activity, the best way to save state is to use onPause in this case, just because then you'll ensure that even if your activity is killed, by some sort of just because the Android device has run out of memory or something else is causing it to be killed, that you can actually resume from some previous state. Yes?
So would this be something you would use to create a start screen, and then, so you would start that first activity, click a button to start the game or whatever, and then close this activity?
Yes, so yeah, this is a great way that you can start a game, for example. You might have a start activity for your game that might be shown on the onset that's, welcomes the user or has a very fancy image and allows you to start the game. That would be a great choice for the initial activity, because then the user can choose to configure the game or to start playing immediately or what have you. And then you might start, rather than have the game run in the same activity, you might then have a second activity that's responsible for gameplay itself. And so then you would use an intent to create a new activity. Then your current activity will be paused at that point and might be killed at some later point in the life cycle. Yes?
I'm sure you just said this, but I don't really understand. What's the benefit of having multiple activities? The benefit of having multiple activities, an activity
it is what it sounds like. So what one activity should do is allow the user to do something. It should allow the user to do one activity, so to speak. And so we might have, in the case of the end puzzle game, for example, we require that you have 3 activities because there's sort of 3 distinct modes that can occur within this game. The very first one would be, say, an image selection, so that the user can scroll through a list of images and then select the one that they want. But the gameplay, it doesn't really necessarily make sense for the gameplay to occur within that same activity, just because that one activity is dedicated to this image selection, or like we were talking about having a splash screen for a game at the onset. So we would have a second activity that's responsible for the gameplay itself. It's an actual separate activity in terms of just conceptually, and so we might actually want to then create a second separate activity for that as well. And so really this is meant to be sort of a conceptual thing, not only to us as programmers, but also to the user, because it becomes very obvious when a new activity has come into focus for the user and that they're going to be maybe switching gears in a sense, that there's sort of a new thing that they have to accomplish within your task, within your application. I guess programmatically, though, there's nothing stopping you from cramming all of your stuff within one activity. It's just that this has been designed to alleviate that problem of you having to dump all of those objects that existed from some conceptually previous activity and then recreating all of the views and doing all of this stuff, when it might make more sense to just follow all of this life cycle in a separate activity altogether. Yes?
If there's a splash screen activity or an image selection activity, shouldn't that kill itself when it's been started the other activity?
Shouldn't a splash screen or image selection activity kill itself?
You don't want it to be restarted.
You don't want it to be, well, yes. I mean, you wouldn't necessarily, I mean, Android will manage the memory for you. It will kill it if it finds it necessary. But there's really, if you wanted it to be killed, then you could actually run finish after passing the intent. But this may not actually kill it until after this activity until the new activity has actually finished itself.
My understanding is, for example, the gameplay activity could be killed in the middle of a game.
Right.
But it would be restarted.
I don't think I understand your question quite yet. Well, so what do you mean? So a gameplay activity, yeah, it could be killed, but it won't be killed
because it needed memory for something else. But Android would restart it.
An activity that's at the very front will not be killed unless there's some sort of major problem, like an exception that's actually caused or some runtime problem. But an activity that's at the front will not be killed by Android.
Well, it's not at the front. Suppose you're playing a game and you get a phone call.
Okay.
Call comes to the front.
Right.
System needs memory.
Right.
Android will kill your activity.
Yes.
But then when you finish the phone call, will it not restart it?
Okay. So yes, when an activity is paused, so it follows this same life cycle. If an activity is paused and it is not killed, then it goes back up to on resume before the game is run. If that activity has actually been killed, then if it actually happens to be destroyed for whatever reason, then it will actually begin again from on create. So you'll then have to be responsible for recreating whatever state the user had left.
So it'll begin automatically.
Yeah, it will begin automatically. Yes.
So the user will just see it pop back up in the middle of the game.
Right. Exactly. Well, that's the intention.
But my point is, the initial activity, what you want once the game starts is for that activity to be gotten rid of and not automatically restarted.
What you want for the splash screen is for that to be, is there
some way I can say, okay, I'm done with this. Get rid of it and don't bring it back unless the user clicks the button to start the program again.
Yes, I mean, when you manage state, you can actually specify in the activity. This is, I think, it'll be better addressed when we start talking about storage. So if you store some state that you are, for example, playing a game and you are remembering the game state in some sort of local storage that persists after the application is closed, or after, more specifically, the application has been paused, then what you can do is you can, in your splash screen, you can actually determine, okay, is the game currently playing? And if so, then you can actually launch the second activity, and it will be responsible for, so it will be completely transparent to the user, but that is something that you would control yourself. It's not something that Android would necessarily handle for you.
My question is, wouldn't it be good for the splash screen activity to get it, I don't know how to phrase the question, to get itself killed so that it won't be automatically restarted?
to get it.
But
So
now it's a waste of resources.
I mean, this really depends. If you want to implement it differently, then you certainly could do it so that your gameplay activity is the main activity, and then when it notices that there is no gameplay in progress, then it loads up the splash screen via an intent. So you could sort of invert it in that sense, and then whenever it does not need to be played, then there's no reason for that activity to be running at the onset. But that would just be basically just shuffling the order that this is occurring. So you would then get what you are looking for, where you would be able to begin gameplay immediately without having to go through this middleman of the splash screen activity. Okay, if you have any other questions, we should probably take them after offline. I think I saw a question back there.
Yes. Is there a way to switch between activities and applications from the user interface on the phone itself? How do you do that?
Is there a way to switch between activities on the user interface of the phone? In fact, yes, there is. So you can notice that here, this is the same thing that we had seen before. Can you start a new activity? If I hit yup, what happens is that there is actually a thanks button that will actually close this activity for me. But there is also one of the buttons down here. Let's see, I don't know if you can see it. It's kind of dark right now, but it's this back arrow. And this back arrow will actually cause the current activity to be shut down and go back to the originating activity. So you might have seen that slide, and I'll zoom back out to make this a little bit more clear. So we can say that I hit yup, and this new activity loads, and I can hit back there, and it will go back to the original activity. But there's no way for a user to specify necessarily which activity they want to see immediately. They could switch between applications, but they can't necessarily switch between activities in the application unless you actually explicitly allow them to go from one activity to the next. How do we switch between applications? Well, you can push and hold down the home button, and you will see a list of recent applications. You can also go back to the launcher screen and launch a new application from there. Yes? Mm-hmm.
You also have it show like an icon show up on the screen, or does it usually run?
When you, in the emulator, can you have an icon show up in the screen? So you mean your application? That is, yeah, actually by default they are installed into the emulator, so just like a real device, but you have to go into the launcher. The home screen that you see is not the complete set of applications that are installed on the device. Usually you have to click a little icon, like in the case of this phone right here, there's that button, that grid-like button. In the case of this HTC that's over here, come on, turn on. There's actually an up arrow button right here that brings up the list of all of the applications. And in this older G1, it looks like this at the bottom. But generally, the icon is at the bottom, and it will bring up the task of, or all of the applications that exist on that particular device. Any other questions? Great, okay, chew on. Oh, one more question, yes?
So how to tell finish to jump to the previous two activities?
I'm sorry, can you say that again? I didn't hear you.
So finish, it tells us to jump back to the activity which you called it.
Mm-hmm.
Is there a way, if there are three activities, is there a way to tell it to jump to the first activity which you didn't call?
So if you have three activities, a lot of the questions are project-based, and yes, I understand. So if you are finished with an activity, one of the things that you can do is that if you launch a new activity and you don't want that other activity to be displayed again, after you launch the new activity, the very next thing in your code could be to finish the current activity. So then what will happen in essence is that once that user is done with this new highest most activity at the top of the task, it will then close back to the second activity, which will automatically close, and it will appear to be seamless to the user. And in fact, I'll show you a demo of what this very thing looks like after this 5-minute break. So we'll see you in 5 minutes. Hello everyone, welcome back. So I just want to talk a little bit about the project. Now, NPuzzle is sufficiently complicated that if you haven't gotten started or even read the specification, I recommend that you do that immediately, like right now. Like, I'm not kidding, it's important for you to get a head start on this project because you cannot do this project at the last minute. It will be good for you to get started on it right away. And in fact, one of the things that we're going to be doing is releasing to you an APK APK file that you can download and install on your emulator. That's a staff solution so that you can play with our own solution and use that to sort of an example to see how we have implemented it. And I'll actually demo that in just a little while. And I do actually want to mention one clarification from the walkthrough. If you watch the walkthrough, we actually mentioned that the images should be cropped to be square, and that's not really correct necessarily. The images that we provide to you may be rectangular. In fact, when I say provide to you, I mean the images that we replace with your own images that you have that you've provided in your project are not necessarily going to be square, even though the game of 15 and the end puzzle more generally is typically played on a square board with square tiles. You do in fact have to support rectangular images. And what I mean by that is that you can have images that are, say, from a digital camera, which are relatively wide compared to their height, or if somebody took sort of a vertical picture of sorts, that it can be relatively tall compared to their height. The main requirement is that you actually divide that image up into equally sized rectangular tiles. Whether or not those rectangles are actually square depend on the image itself, if the image itself is square. And again, I'll show you a demo of that in just a little bit. And so one of the things that I do want to mention is about grades. So just to reiterate, there's the 4 axes that we talked about last week, and generally you're going to receive feedback on them in one of 3 things. It's either going to be a check minus, a check, or a check plus. And the check is going to be the most common grade that you will typically receive, and that means that you've met your project for that axis is good in that respect, and that it's satisfactorily met the requirements for it, even though there might be 1 or 2 maybe minor problems for that particular axis. You might still receive a good rating of that, which just corresponds to a check. Now, a check minus means that it's deficient in some major way. Maybe there's a couple of show-stopping problems, or maybe even a couple of problems that or even one major problem that really prevents it from doing well in that particular axis, and that implies that project needed a bit more work in that area. Now, you're not going to find as many check pluses, except perhaps in scope. So scope is the one thing where if you implement all of the things as required in the specification, then it's really relatively easy to get a check plus in that respect. But a check plus means that that project is essentially perfect in your TF size. And what that means is that there's really no comment that TF might have for that particular axis, which means that you've done really, really well in that aspect. And that's going to be kind of difficult to achieve. Now, to do well in the class, you're going to start out with probably quite a few checks, maybe some checks minuses, and that's okay. That's going to be fine for these early projects. But the goal for you as you start working on some later projects is to start getting more check pluses. And really the general trend should be an upward trend in the checks and check pluses that you are getting in your projects. If you do that, then you're going to do well in the course. And we are actually going to normalize all of the grading across all of the TFs. And because there's quite a bit of calculation that's going to be involved, we can't actually provide to you a letter grade immediately, at least this early in the course. So we're unfortunately not going to be able to provide that to you quite yet. And basically, I know that some of you have questions about weights. Generally, or not generally, but the setup projects will be worth less, or worth not quite as much, at least not worth less in the grand scheme of things. They will be worth not quite as much as the other projects, just because, as you can tell, the setup projects are not as complicated as these other projects, especially the staff's choice and student's choice projects that we've made available so far. So I've mentioned so far that we will actually make available to you an APK file, and so this APK file, which you can see right here, actually loads up an application that does an implementation of the end puzzle. Now, I will say that I went a little crazy in this implementation. It actually does implement things that you do not have to implement on your project. Specifically, you'll notice that this list right here includes not only the name of the image, but the image itself. That's not required by the spec. It's just sort of a nicety that I found nice in this particular case. But it does actually work as expected in that it will actually open up an image. Excuse me, gosh. it will resize it to match the maximum size of the screen. Now, I know that there have been some questions about orientation and such, and again, you can refer to the staff solution to see how we interpreted the specification in this case. And also, one of the things you'll notice is that we even went so far as to randomize the tiles and make sure that they are actually correct. And again, you don't have to randomize the tiles, you just have to make sure that it's shuffled and in a solvable position. And I will recommend that you actually download this APK file, which we will make available on the course webpage probably a little bit later tonight, and you will actually be able to play with this. Now, some of the things that we talked about before is what happens when we actually open up an activity and we want to close immediately to say, let's say we have a couple of activities in our task. We have our very first activity, and then we open up a second activity. And what happens after we've finished this one and we actually bring up our third activity? You'll notice that in this case, one of the things that we do is, under pressure, there's no way I'm going to be able to solve one of these end puzzles, but basically, once the new activity appears, there's a little button that says, go me, congratulations for winning this. And when you click that, it closes not only that activity, but also this gameplay activity and returns back to the original list. And again, there's a lot of things, like I mentioned, that are implemented that you're not going to have to worry about, like, for example, the images that are here, let's see, I don't know if it's going to do it now, but the images that are here are actually lazily loaded, as you can see, as they're resized dynamically from the resources folder. Again, this involves threading, something you're not going to have to worry about. But the major aspects of this implementation might actually help you get started, or at least compare how you are implementing it with how we decided to do it as well. And so you'll notice that even though this does match the specification exactly, there have been some questions about orientation. One of the things that I want to mention is screen size as well. So if you notice when you start working with the screen sizes that even on a device that uses a very high resolution screen, it might actually report to it that it's using a lower resolution screen than what exists on that device. Realize that that is due to the fact that we are targeting a very early version of Android, and that early version of Android 1.5 does not actually have support yet for high, at the time it did not have support for high DPI screens. And so what happens when you run your application that's targeted for 1.5 on a newer version of Android, as is in the case of this app, of this phone here, and would be the case on this HTC as well, is that the phone, the Android OS rather, reports a generic size. It downscales, it creates a so-called virtual screen, that it sort of downscales the current resolution of the screen down to the version that is supported by version 1.5. In short, I wouldn't worry too much about this. If you do proper layout, if you actually design your puzzle so that it lays out properly, then it is going to be properly upscaled to match the resolution of the newer version of Android. It's not something that you're going to have to worry about. And you can, in fact, create all of your layout and test it and I, of course, recommend that you test it not only in versions 1.5 of the OS, but also newer versions with the high resolution screen. You'll notice that even though that the application itself thinks that the screen resolution is a little bit lower, it's up-resed enough sufficiently by the Android OS so that it does not become a problem. So in short, if you notice that the screen resolution is lower than the emulator, that's fine. You should still create your layout as appropriate for that screen resolution. But what's going to happen is that the Android OS will deal with this automatically. Oh yeah, I was happy also with these little animations that exist there. Another thing that you don't actually have to implement. So we will make this APK file available for you to download on the staff page a little bit later. Any questions on this before we move on? Yes?
Your last remark about the animations not needed to be done by us. What did you mean exactly as you touched them and they moved?
Oh, so, well, you'll notice that when I tap on a tile, it actually slides to occupy the other. That's not a requirement that you animate the swapping of these two tiles. It's certainly acceptable to just have those two tiles swap just quickly without an animation. And so the animation is not required in the spec. And again, in the specification, if there's something that's not if there's not something that's explicitly required from it, then you are allowed to interpret it as you wish. Yes?
Can you speak a little bit more about the proper way to set up a layout so that it scales properly? I tried the code from the walkthrough demo and it didn't up-res?
If it doesn't scale properly, so so what is most likely happening is that it is not this issue of scaling from this sort of virtual size that I had just mentioned up to the actual screen size, but what might be happening is that the layout itself is not becoming large enough to match the maximum size of the screen. And so there might be some, and it's sort of a generic question, so it's really difficult to speak specifically about what might be happening, but it could be in the way that whether the layout is defined programmatically or using XML, it could be in the way that it is just being laid out, frankly. Yes?
Oh, I just was wondering, what kind of board, how did you get that border on those tiles? Because
How did I get the border?
They're slightly indented, and I can add padding, but it looks almost like these have a white outline.
Yeah, so these do appear as though they are sort of beveled a little bit, or they sort of pop out in a sense. This is, so really again, the spec just mandates that you have a noticeable border between tiles. It doesn't say that you have to have this sort of fancy border here that you see here, but basically these are, without going into too much detail, the tile image is the foreground image, and there is a background image that creates this illusion of the border around the tile. Yes?
I noticed that here your application is taking the entire screen, but on an emulator you often see an additional top bar on top of the screen. And
Yes.
Just use screen dimensions. How do we take into account the top bar, or how do we hide it so it does not?
Yes, so you'll notice that in this application it actually hides all other aspects of the UI, including the very top menu bar. In one of the later demos that I'll show in just a little while, I'll actually show you it's with this very relatively simple attribute that you add to your manifest file in each activity that specifies that that activity is meant to be full screen. And so we'll talk about that in just a second. And that's actually really quite useful, I think, not only for this application, but for a variety of other ones as well. Okay, so let's move on now, just because we have quite a bit of code to go over as well. And so we were talking before about creating some additional intent. So we mentioned before that in code, in Intent 06, we were able to start up a new activity. And this new activity, just to sort of prove the point that it's completely unique, notice that in the main activity, we set the content view to the XML file known as r.layout.main. And in the new activity, we're using a completely separate content, a completely separate XML. This isn't mandated. You don't have to use separate XML files. But usually, when you switch from one activity to the next, you're certainly going to want to have different layouts because each one is going to be relatively unique. So in this case, it goes through, again, the same creation process, the same lifecycle process that we had been talking about before. So in our new activity, we create an onCreate method, and we do everything as though this activity is like our sole activity that we had been working on before. And so you'll notice that this is very relatively straightforward code compared to what we had seen before. The only thing this button is supposed to do is just finish the current activity that is reflected. And recall that this was the very first activity was the black screen with the two buttons when you clicked yes. The new activity with the white background appeared and the thumbs up clip art, and that allowed you to click the button and move back. Now, we've mentioned before about how you can actually start activities not only within your own application, but other activities as well. And that is the point of Intent 08, or rather Intent 07, where what we want to do is open up activities that do not belong to our current application. And in fact, you'll notice that in this application, we only have one Java file, code7.java, but when we look at this application on the device itself, we will see that it actually has a variety of buttons. Let me zoom in a little bit, and each of these does a number of things. So all of these are different intents, or rather that are different activities that exist on a phone. And it's important to note that some of these, I apologize, the cable is sort of causing some torque on the device, and so we get this slantedness that exists here. Oh, wait. There we go. Okay, so now realize that some of these applications, some of these activities don't actually exist in the emulator, and I'll talk more about that in just a little bit. But what this means is, let's say that I want to open up a map. You'll notice that a new activity is opened, and even though I don't do anything, it essentially opens up the Maps application to a specific location. In this case, I've set it to be El Paso, Texas. And if we hit the back button, what we can see is we go back to our come on, we go back to our initiating activity. So again, this is a task. This really hammers home this idea of a task where this is really two different applications, but to the user it appears as though it is one task that we've been referring to before. So this is my application right here, and when I click on one of these other ones, let's say that I want to start an SMS, for example, then I click SMS, you notice that this actually brings up a new menu that allows me to choose how I want to implement this intent, or which activity I want to use for this intent. So I can choose either Google Voice or messaging. Let's see, perhaps a different one would be to use URL as an example. And so this really looks like, man, I have multiple browsers on this phone as well. Oh, just stop it. And so now it loads up the default browser, and it appears as though it is all part of the same application. And so what this looks like in code is actually it's actually not very difficult. But when we want to create an intent, recall that one of the things that we can do is pass into it some data. So in this case, notice at the very top we have here, we're creating a new data variable that is of type intent, and we're instantiating an intent within it, and we have to specify some data as well. In this case, for almost all of these activities, if not all of them, what we are going to do is set essentially some data with two methods. First, set action, which tells what action we want to do with each of these activities, and then the other one is the data itself. And most of the time, the data will be in the form of a URL or URI that is then interpreted by the Android OS, and then it determines based on the URI which is the proper activity to open. So in this case, notice that we want to, in the case of the URL button, we actually want to view in this case, and the URI that we want to view is this. Now, because the protocol is HTTP, when we actually open up this activity, the Android OS then looks through all of these intent filters that it has sort of stored in memory, and it will say, okay, I am looking for an intent that allows us to view a URI that starts with the protocol of HTTP. And so there were, as you could tell, a couple of different browsers that actually were installed that allow us to do this, and that's why that browser picker came up on the device itself. So I can actually pick, me as the user, what application I want to use that will be able to accomplish this goal of opening this activity. Now, if I actually wanted to open up the phone application and cause the number to be dialed and not necessarily called, then one of the things that we need to do is use this URI. Instead of HTTP, we would actually use the TEL URI, and there is a variety of other ones as well. Now, I mentioned before that not everything is installed on the emulated device. In fact, by default, there is no Google Maps application. So what you will see is that when you try to launch this activity, this map activity right here, because the Maps application isn't installed by default, most likely, unless you are catching some exception, you are going to get a crash, just because there is no activity that is able to be opened that interprets this URI that starts with geo. And so this really does depend. And so you'll have to, if you're opening activities that are from other applications, you will have to be a bit careful when opening them, just to make sure that you are able to do so and to handle any sort of problems that might occur as a result. And so you might be saying, well, how then do I know what some of this, what data that I actually wanted to use? Frankly, you have to look in the development sites to see they have a list of some of these. There's a variety of them, including the SMS, the map, and the telephone and the URL that allow you to create intents with the specific action and a specific URI that will be loaded by the default applications in each of these. But sometimes you have to just sort of look around on Google, for example, to find out what some of this extra data might be. And so notice I didn't actually show this on the demo, but and let's see, I just want to make sure that this looks correct. Okay, so on the screen here, when I click on SMS, notice that when I click on messaging, what happens is that it actually loads up the telephone number that I had provided as well. And so there's some additional data that you can do, that you can send to each of these activities using this put extra method that allow it to do some things. And so you can also do the same thing for email, so on and so forth. So in the case of this activity, we're actually able to determine if an activity is not found for some reason, and we will show a toast to the user that there is no way of opening the requested activity from another application. I think I saw a question.
Yeah, so is there any other way to specifically call an activity instead of just allowing the OS to choose a default activity. In this case, for example, SMS, you want to specifically use, another activity instead of allowing the OS.
If you want to use specifically another activity, I don't believe so. You have to, in order to initiate an activity, you have to use intents, and it is going to use an intent filter. And this allows the user, because perhaps they no longer want to use the default SMS app, for example, then this allows the user to continue using their own preferences for whatever the intent happens to be that you are trying to initiate. So I don't think that there is a way of overriding the user's preference in this particular case. However, you can do the opposites, and you can force, even if it doesn't ask you, you can actually create, or you can actually use the intent.createChooser to force the choice upon the user when there might be a couple of activities. You can actually force the user to choose which application to use for a specific activity. Yes? Is there a possibility of installing market applications on the emulator? This really should be something that I should have tried, but I actually don't know. I've not actually ever tried it, mostly because I have hardware devices that I do. Does anybody happen to know if you can install market applications on it? You can. Right. So, well, yes. So, yes. I mean, you can obviously install any application you want on the device, but the market application itself, it sounds like that is not actually included with the emulator. So you might have to then. Now, one of the nice things about Android is that you can actually install applications by URL. And so one of the things when you download this NPuzzle staff solution, for example, you'll actually enter into your browser the URL that you want to download this file from, and then it will be able to install direct from the browser after it has successfully downloaded it. Okay, so this is then, so we've seen a couple of different things using intents. First, we've seen how we can start an activity local to our own application on top of our task stack, and also how we can open up other activities that belong to other applications. And if you are interested in trying to initiate an activity from another application, best usually is to find what the action and the URI are for that specific application, either by Google or by looking at the if it's a third-party app, perhaps that application has an API available, then you would be able to see what intents or what filters are necessary to open up that intent. So now what happens if we start building all of this stuff together into one large application? So that is the purpose of Intents 08, where basically what we want to do is create an application whose sole purpose in life is to be an image gallery. And so what this will then look like is something like this. And so there's a whole bunch of things that we have talked about and not talked about quite yet that are involved in this particular application. And we can see that if one of the things that's supported here is we can see a whole gallery of images. When we select one, it actually opens up a new activity. Now notice what happened when we opened up this new activity. At this list of images, there's the status bar at the very top. When I click on a new activity, that status bar actually slides away. And so this is one of the things that we're going to be talking about. And clicking on that image then returns us back to this original activity. Now, I had sort of waved my hands either last week or the week before when we talked about adapters in a list. And this is the application that's really going to show the power of adapters, where you can really define the data that exists within a list using an adapter that you are able to create by extending the class of another adapter. So when we're looking here at code 8, realize that there's a couple of different activities. One of them is that initial activity that you saw, the list of images. The other one is the second activity is the one that shows that image in a larger preview so that you can then just see that image in a larger screen. And so we have a couple of activities to go over, but also this first activity it uses a view. It uses a grid view, and for us to populate that data, we have to use, in order for us to populate the grid view with some data, we actually have to use an adapter that we've also created. So we have here then in the source code, in the source directory, 3 different files that we use to complete this application, even though we only have 2 activities within it. One of these is just a class that we are using that acts as an adapter for this grid view that provides the data back to this grid view and shows us the images that exist within. And in fact, this Intents08 is going to be sort of a not quite so small / big hint towards achieving at least the first activity in your NPuzzle application, just because the images that are provided in this image view belong, or they exist right now in the drawable directory of the resource folder. And in this case, there's no data other than the list of images that exist within this directory that specify to the application what images are actually there. We could add or remove images, and they would be updated by the grid when we load it up next time. So how is this actually accomplished? For us to take a look at this, we have to, of course, take a look at code8.java. And so one of the very first things, of course, the first 2 lines are very obvious to us, but now what we're going to do is instantiate or connect to a grid view, a layout that we have already created in an XML file, and we just want to connect to the grid view that exists within that layout. And the grid view by itself is just an empty view. It can't display any data, but the data that we provide to the grid view will be displayed in that grid like you had seen. But one of the things that we need to do using this adapter is to provide back to this grid view all of the images that will be shown in each grid. And so this is the point of the adapter, is to be an interface between the view and our data and provide to the view the data that we actually want to display. So that's what's happening in these first few lines here. We're connecting to our grid view programmatically, and then we have to set the adapter to provide the data to this grid view using the setAdapter method that exists here. Now notice that we're instantiating something called image-adapter. An image-adapter, like you might recall, is actually a class that was created as part of this code. It is right here in image-adapter, and we'll see what this image-adapter looks like in just a moment. Now to sort of round out what's happening here, recall that when we clicked on one of the items that we were able to bring up a new activity. So as you can tell, there's probably an event handler of some kind, and we tell the grid that we are using the current activity or the current class as the onItemClick listener. And this onItemClick actually accepts quite a few parameters, as you can tell, including the parent, the current view, the position, the ID, and all of this stuff is important, as we'll see, and we'll actually have to implement in the image adapter in just a moment. But pay in particular attention the ID and the position, which we use as a way to pass some data to our next activity. When we want this other activity to actually display an image, one of the things that we provide to it is the resource ID of the image that we have selected. So in this case, what we are doing is we're creating a new intent, and the way that we can pass data from one activity to the next is to put some extra data into the intent using the putExtra method. So in this case, it uses key value pairs. So I've specified the key here as image to display, and then the ID is the actual ID of the resource itself that is going to be displayed by the subsequent activity. Then I start that activity. So what happens in the other activity then hopefully is relatively straightforward. And what we do is, of course, we onCreate, we instantiate all of this stuff, we connect our views, and what we do is we pull the extra data out of the intent. And so that is provided to us by a bundle object. So I've created a new bundle object, and from that, I'm requesting the extra information from the intent that was used to start this activity. So in this case now, extras is a bundle, and using this bundle, can we retrieve the value that's associated with the key? So notice that here there is a method called getLong, because in this case the ID was a long rather than an integer, and I provide to it the key, and now that is then casted into an int because all of the resources are going to be integers. And so now the resource variable holds within it the data that was passed to this activity from the initiating activity through the use of this bundle. that was then bundled into this intent object. So then from there, we kind of do the obvious thing of sending the image resource of the image on this new activity to that was passed to us. Yes?
Activities subsequent to the second activity, would they have a handle to the same extras here? Or?
Subsequent activities would not have the same data that was passed to this one. You would have to explicitly send in a new bundle, in the new intent object, that data. You could actually, I suppose, do it by interpreting all of the extras that you have within here and then bundling it into your new activity and passing that along. But most likely this is going to be a manual rather than an automatic process.
It's almost analogous to a web app, like a HTTP request code.
It is a bit analogous to a web app in that if you are requesting a new URL, you can provide key value pairs that specify some state. That is certainly what's going on here. We are providing a key value pair that tells this new activity what we should actually do, or what it should actually do, or the data, more specifically, that it should be acting on. So now, oh, yes? Oh, yes. Resource IDs, well, in this case, everything is local to this application. So the resource ID I'm passing is local to this application, and both activities are local to this application. So because it all belongs to the same package, then we know that it is going to be able to reference it. If you actually wanted to pass some data to, say, a file to another activity altogether, what you might have to do is, I guess it really depends on how that activity is expecting the data to be passed to it, but most likely you would then have to save that data into some sort of safe zone because other applications cannot access the data private to this application, so you'd have to store it publicly, say on the SD card, and then pass perhaps the path to that file to subsequent activities. Yes?
In order to have an ID, does the drawable have to be listed in the XML file?
In order for this to have an ID, does the drawable have to be listed?
Just putting it in the folder, just putting it in the drawable folder isn't enough.
Well, recall that automatically generated for us is the r.java file, and this is the map of drawables to their respective IDs. So in this case, one of the things that we're doing, and one of the things I'm going to show you in the image adapter class, is that we actually pull this information. We find all of this information that has been pre-generated for us, and we store it into a list, basically, so that we know what the ID of each of these images are, and then we're just able to pass that ID along to the next application or to the next activity.
In other words, the answer is no, it doesn't have to be in the XML file.
It doesn't have to be in the no, it does not have to be in the XML file. It is generated by Android and placed into the r.java file. Yes, yes.
Your on-item click function, it only seems to be using the ID, so why are you passing it those three other parameters, like position, view, and...
So on this on-item click, why do we have all of these other parameters as well? In order for us to properly implement the on-item click listener, it requires that we create a method called on-item click that accepts these parameters. So even though we don't use them, in order for that listener to be called, it has to be implemented in this manner. It's mandated by the interface. Yes.
How does the program know, if it's not hard-coded, what IDs exist?
That's what we're going to talk about right now. So how does the program know, if it's not hard-coded, how these IDs exist? In order for us to do this, we have to use a concept in Java called reflection, where we can actually inspect the class that exists to query it for the fields that it might have and the methods that it might have. And this applies generally to Java as well, but we're using it specifically in this case to find all of the fields that exist within the r.java, the r.drawable class. As you can see from the R file, hopefully I have it open here, there is an R class, and then it has within it a drawable class. We want to retrieve all of the fields that exist within that class so that we can get a list that has been generated by the Android at compile time of all of the resources that are available to us. So in this image adapter, what we're going to do in the constructor is actually a couple of things. First, we're going to get the fields from that class. And to do that, we're going to specify the class that we're going to get the fields from, so r.drawable, and then we're going to specify that we want to get the fields from the class. And we put that into a field list. The field is just a data type that, that exists for the purposes of this reflection. So now this is just an array of fields that is contained within this r.drawable class, and we can iterate over all of these fields. We can request not only the name, but also the ID that's associated with this field and do something with it. So notice that this fields list includes everything within the drawable directory, including the icon. So we might have other drawables as well, but we're going to have to select which ones are the images versus which one is the icon. And the way for us to do this is just to ask what the prefix is. So you'll notice that we've prefixed all of these in a very known way. All of these images that we want to display start with the string img_. So we can select then the fields that we want by looking for names that start with that string. And that's exactly what happens. Now there's a whole bunch of ways you can do this. Some of you might raise your hand and say, well, why didn't you implement this with an array list, which is a dynamic array, which does not have to be, you do not have to specify the number of indexes within it. But the reason that I did it this way is just to show one way that we might do this. So the first one we want to do is count the number of fields that exist that start with img_. The reason that I do that is that after I've counted them, then I can create two new arrays of size count. So I know then, once I've counted the number of fields that start with img_, that I know how many exist. So now I can create my array and allocate the proper number of items in each. Now, of course, again, you can get around this by using an array list and having that be a dynamic array instead, but this is just one method that we can use. So from there, we then want to get, so notice I sort of glossed over this. We had all of those fields in this array called list. We wanted to get the name, which just returns to us a string, and one of the methods of the string class is starts with. So we can just ask very easily does the first few characters of this string match that of img_? So now we have created arrays with the proper number of indexes, and now what we want to do is populate these arrays with the values from this field list. So what we are going to do is rather unsafely, because in order for us to do this we have to catch some exceptions, but what we want to do essentially is iterate over the entire list and get the name, make sure that it starts again with image, because we haven't modified the field list at all. We want to make sure that we're still working with the same data, and if we find one, then what we want to do is place into our images array, which is just an array of integers, the actual ID itself, which is of type integer. So what we are saying is from that field item, what we want to do is get the integer and place it into an array that we are just caching this array of IDs that correspond to the list of images. Now again, I'm going to have to we're sort of running out of time a little bit, so I'm just going to sort of wave my hand at these exceptions. But generally, when you retrieve the data from a list, you have to make sure that you implement some exception handling as well. In this case, illegal arguments exception and illegal access exception. Don't do this. This is not very good. This is just meant to be very general, just sort of a quick and dirty implementation. What you might have are two separate catch blocks that catch each of these and do something appropriate if you happen to get these errors. So now, some of the things that we have to implement within this adapter include getting the count of the adapter. And that's the number of items that exist within this adapter. So recall that we have now generated the list of items and placed that into this images array, and we can find out exactly how many we have as a result by just recalling the length of this same array. Now, if we actually want to retrieve the ID of a particular item at that position, then when a position is passed to us, can we return the ID that's contained within that array at that specific index? So all we're doing now is we're just saying that this item has a specific ID, and that ID is provided to us by the actual drawable ID that we have calculated, or not calculated, but stored into this images cache. Now, the sort of important part of this image view, or rather image adapter that extends a base adapter, as you can see at the very top here, we're just creating our own adapter that extends this base adapter that provides to us a minimum amount of implementation. One of the things that's most important is this get view. When this list is actually being created, it actually calls the image adapter's get view so that we can generate some arbitrary view that represents this data that we have stored into memory. In this case, we don't want to just show the IDs of these images, but what we want to do is show the image itself. You might recall from the grid view that it was the images at each location. So each of those is a separate view, and in order for us to display those, we have to get the view at a particular position. So there's a couple of things that happen here. And now the important takeaway I should make clear from this for the NPuzzle project is in fact this reflection aspect. You really, unless you really wanted to go all out in your project, you're not going to have to create an adapter necessarily, but what you are going to have to do is figure out which drawables exist within, at compile time, exist within your drawable directory, and using reflection is the key to that. Only if you're going to do something relatively complicated, like generating a complicated list view with some arbitrary view, like say a selection of images or an image thumbnail directly adjacent to the image name, are you going to have to use an adapter in this way. But using an adapter then, if we need to create a view, we get passed to us a couple of things. And notice that there's a position that indicates to us what is the position of the view that we're actually trying to show. So in this case, we would then know, okay, well, I know that at position X, I need to show image X as well. And so we can then, into the view, convert view, implement, or display, rather, this image that we have selected. So what happens here is that we basically just create an image view. You'll notice that here we create the image view, and what we do is we create a thumbnail of that image using Bitmap Factory, and then we set into that image view the bitmap that we have just generated. So recall that these are very large bitmaps. These are large bitmaps, or rather large JPEGs, that are in the drawable directory, and in order for us to display them in a grid view, we can't just have the Android OS just use the resource ID and just sort of resize it for us dynamically. If we were to take the lazy way out and not actually resize into a separate thing and use something like imageview.set image resource, the image at that particular position, we would very, very quickly run out of memory, just because Android is trying to then load all of these images in their original form into memory and resize them dynamically, and that's not going to fly. So what we are going to do instead is load one image, regenerate it to be a proper thumbnail size, and then cache that regenerated size into a bitmap cache. So that bitmap array that we had created in the constructor method of this class, we're actually just going to populate with pre-sized or resized versions of each of these resources. So from there, then, are we able to set the image bitmap of that image view to that cache at that particular position. And notice that one of the things that we do is we actually check to see if this position already has a cached bitmap available to us. And the reason for that is the way that this view actually works. Notice that we have a bunch of images here, and not all of them are visible on the screen at once. Anything that's not visible on the screen, Android recycles. There's a certain number of views that can be displayed on the screen at once, and it's not going to create a separate image view object for every single item that exists here. Instead, what it is going to do is create only as many image views as is necessary to show them properly on the screen, and it's not going to create in memory anything else. So what this means is that when I start scrolling down a little bit, the top row images, and you're not going to see this actually, but you can sort of see a very slight delay that happens when a new image row appears, is that that very top row is going to be recycled. Those image views are going to be passed back to this getView method, and this getView method is going to be responsible for converting them from their previous thumbnail to their new thumbnail to be displayed on the screen. So this means that it's recycling a lot of objects, just because object creation is very expensive, garbage collection is expensive, so we want to create as few objects as possible, and the way that we can do that is by recycling these views. And in fact, when we go back to this code, notice that one of the parameters that's passed to this method is a view called convertView. Now, this view might be a recycled view. So in the case of us scrolling up in this set of images and that top row disappears, those image views are no longer going to be there, but they are instead going to be recycled, reused, so that new objects don't have to be created in a new bottom row that's going to appear in just a moment. And so we get past this view that might already have an image view associated with it. This might actually be an instantiated image view and might already have an image associated with it. And so what we need to do then is check to see if that's the case. If convertView is null, because say it is actually creating these objects for the first time, then what we need to do is create a new image view, instantiate a new image view, and set all of our data associated with that. Otherwise, what we are going to do is say that our image view is basically just this recycled convert view. Now, in this case, this means that we now have access to whatever this view is, whether it's a newly generated view or a recycled view. And what we can do then is populate it with the appropriate image that we have either pre-generated. If we've pre-generated it, then we're going to skip the generation of the thumbnail, and we're just going to set that image view equal to the bitmap in our cache. But if we have not yet generated this image in our thumbnail, notice that if cache at index position is equal to null, then we have not generated our thumbnail yet, so we need to generate it, and then we are able to set our image in this new, whether it's a new image view or a converted image view, equal to this bitmap. Then what we do at the end is we have finally generated our arbitrary view, which in our case is just a collection of image views, and we return the image view back to the adapter, or back to the grid view, which then displays it on the screen for us. Now, I'm sure there might be a ton of questions, but I do have to mention a couple of other things as well. And just very quickly, we've talked about how we might be able to save state. There's a couple of storage projects, Storage 1 and Storage 2, that actually demonstrate how we might save persistent storage between running each of these applications. So in this case, what we want to do, it's actually very, very simple for us to save state. And recall that in the activity lifecycle, the time for us to save state is on pause, because that is the time that we might have an activity that's killed. And so what we need to ensure is that we actually save all of our state in on pause, just so that we are guaranteed that we have saved the state in that case. So for us to do that, we implement an on-pause method. Of course, with all of these activity lifecycle methods, do we have to call the superclasses on-pause method as well. Then we have to create a new object of type shared preferences rather. And you'll notice that what we're doing is we get preferences. We'll talk about what that means in just a second. And we create a new editor. And in that editor, do we place the data that we want to save? Now, the data that we can save into the shared preferences object is simple data. It's very much like this local storage from HTML5. You can place integers, you can place strings, you can place primitive data types, but you're not going to be able to place things like arrays or anything like that. You're going to have to do something so that you can actually convert an array, if you have one, of data into simple data types that you can then place into this editor. So notice that what we are doing is, again, this is key value pairs. We are placing into this editor with the key default char the data selection, and we are then committing to memory this data that we have stored in the shared preferences. And this, just to give you context for this application, this builds upon that application that we saw that had the two different cars that we could select based on the image, or rather based on the menu selection. And all this does is it builds upon that to save the selection that the user has set. And so all we're doing is there is a field variable called selection that refers to one of the two cars, and we are putting that into the default car. Then when this activity is created, we actually want to see if we have stored any data into the preferences. So what we do is we create another shared preferences object that we call prefs. We get the preferences, and mode private just means whether or not this data is going to be public to other applications. Almost always is it going to be mode private, just because that means it's local only to your own application. And we are going to get an integer from our preferences of key default car. And if this happens to not exist for whatever reason, because say no preferences had been set yet, then we'll just provide a default in case that no data actually exists within the preferences. No preferences have been set yet. Say it's the first time that this application has actually been opened. We were able to get some default data here. Now, storage O2 is basically the same thing, but it allows us to use shared preferences. This get preferences method and the shared preferences storage that we saw down below is actually specific to one activity. So if we had multiple activities in this application, we would not be able to retrieve the data from the first activity. If we wanted to share these preferences across both, that is the point of shared, or rather of storage O2. And in this, you'll notice that there's two activities, but what we want to do is actually fetch preferences from the get shared preferences method. And the only difference is whether or not these preferences are shared from multiple activities within your application. So if you have multiple activities and you want to share the preferences across multiple of them, you're going to want to use this get shared preferences and provide it a name. Notice that we've given a name to these preferences, in this case code2 prefs, that allow us to pull the data from that preferences object. But all of this stuff, I recommend that you take a look, you download this source code, take a look at it. There's quite a few comments, and again, we're going to be going over all of this in section as well. But with that, thank you all for coming. Good luck on your end puzzle project. We will see you next week for the final Android lecture. Oh, thank you.